Alhamdulillah, sir.
Was it difficult in the exam?
No, sir.
Okay, fine. Actually, where we have left before mid, that was the power flow, right? The power flow analysis or power
Yes,
flow,
sir.
load flow analysis. So, if we can think, recall that issue once again, what we have covered, we have different categories of bus. Those are the bus criteria or category: slack bus, load bus, regulated bus. And all the bus must have how many parameters? How many parameters should be there for different bus? Say for example, if we select slack bus, which information will be there for slack bus? Slack bus will have the voltage information and phase angle information, right? Magnitude and phase angle. Then slack bus will sometimes known as swing bus or reference bus. The other bus criteria is load bus, where we have only PQ information. And regulated bus, we have the PV information. So regulated bus sometimes known as generator bus as well. Okay, and that bus, the voltage should be maintained or regulated, or you have to keep the voltage in a constant value. That's why it is mentioned regulated bus. Okay, so the four information for different bus is voltage, phase angle, real and reactive power. Okay, these are the information for different bus. Out of that four, two information will be given, and based on those two information we can select or we can say which categories of bus this will be. If the information for voltage and magnitude and phase angle is there, we can say this is the slack bus or swing bus. The other bus will have P and Q information, which is load bus and regulated bus PV. So based on those bus criteria, we have the power flow general basic or important equation, which is based on KCL concept in terms of admittance Y. We know how to generate that equation based on KCL, right? And you have another power expression, complex power expression. From these two current, we can have the generalized expression. When we equate these two current in terms of complex power and KCL, we can get that equation, and that equation can be simplified in terms of voltage. This is the very important equation for load flow analysis. Okay, remember that, or you can generate that from the basic idea. How you can generate that, it is already discussed or mentioned in the before mid topics. So power flow equation, if it is the power flow equation, uh, can we find the real and reactive part from that equation? After some simplification, we can generate real and reactive part, right?
Yes, sir.
If we want to get that, actually that real part will be positive, reactive part is negative in the equation. So when we equate that formula, this will be the real part R, and imaginary part negative sign, actually minus Q is multiplied by negative sign. That's why it is there, minus sign. Okay. So this is the minus sign issue for reactive part, because the general equation has already negative sign. Due to that negative, you have Q as negative. Okay. Negative for imaginary part. So if we have this idea, we for PV bus, voltage and power information will be given, right? PV bus.
Yes, sir.
If voltage is already in your hand, uh, the you have to maintain that voltage on that magnitude. So if you make the calculation for voltage from the general equation, you might have deviated result or different response than the constant value which is already given. So what you have to do, you have to determine the error calculation for that. To keep your voltage on that particular constant value, what will be the error limit? This is the error calculation. Okay. So for PV bus, you need to consider that error calculation. Now we have to check line loss is already mentioned. How we can find the line loss? Actually, if we have two bus, in between them the power flow will be there, right? From bus 1 to bus 2, or here you have bus I to bus J. So bus I to bus J, you have the power flow, and that power flow will give you line loss or loss due to line flow. Okay. So how can we get that from a complex power in terms of Sij? This will be the Sij expression. Sij can be determined from Vi into current complex conjugate, and Sji Vj into current complex conjugate. So from these two information, we can find the loss. When we add these two, we can get the line loss. Actually, Sji will be negative sign. That's why you have to consider the addition. Before mid, we have discussed about that problem. If you can remember the 3-bus system, actually in that 3-bus system, what are the different categories of bus we have in this diagram? We have slack bus. For bus 2, which type of bus this one? Bus 2.
So load bus.
Load bus, as well as it can be mentioned PQ. Okay, load bus is sometimes known as PQ. Load bus or PQ bus. Bus 3 is also load bus. So load bus is 2 load bus and 1 swing bus or reference bus. So swing bus sometimes known as generator bus or source bus. Okay. So 1 source bus, 2 load bus. So we know how to handle that problem based on the formula. And what is the value in between two bus? Which value is this one? What is this? This is
Sir, complex power.
complex impedance, right? Not power, it is the impedance. Power is there, right? Power is this one. Power should be mentioned by arrow sign, but it is the impedance. Okay. So if you have been given impedance, you have 3 impedance for 3 line, between 3 line. So can you find the admittance from that?
1 divided by impedance.
Right. From the reciprocal relation, you can generate the admittance. First calculation. So after calculation, you can generate the admittance, and from there you can, this will be the admittance diagram. Okay. So admittance diagram, you can get the response of voltage, which is already mentioned before me, how to calculate that voltage. and the other part of voltage, two voltage you have to determine because two load bus is there, V2 as well as V3, and after 7 iteration you will reach the result. So yes. Forgot? Okay, fine. Can you recall the equation? This equation, very basic equation. Okay. Actually, in that equation, you have some power. This is power due to complex power. When you equate two current, actually current in terms of KCL equation and current in terms of complex power, you can have this equation. And in that equation, this is the scheduled load. Actually, scheduled load was the demand, or this, that means uh, this is the load side, right? Load side will have uh, the consumed power, and source side it will be the load delivered power from the bus. But in bus, load bus, it is the consumed power. So when you use scheduled load, SCH, or this one, you have to use negative sign because this is the consumed load. If it is the source bus load, in that case it will be positive. Okay, as it is the load bus power, you have to use negative sign. So scheduled load is there, and as it has 100 MVA bus, 100 MVA system, you have to generate per unit based on that. These are the power information already given, and it is converted to per unit. Then this power you have to put in here. It is the admittance information. Okay, admittance for bus 1 to 2 as well as the voltage. Actually, when you use that formula V2 and V3, be careful about the iteration level. For V1, as V3 is not given, you have to consider V3 initial value as 1. Okay. So after calculation, you have generated V2, and when you get that V2 for V21, that means generate the V3 iteration, you have to put that value as V21. Okay, V21 will be there and V31 there. Then after some iteration, you will generate the V2 and V3. Actually, 7 iteration, you will reach the desired result. Okay. So if you can have the issue of power. If you check this expression, okay, what are the necessary parameter? Admittance, voltage, and power. Power is already given. Admittance you have to determine. Voltage for slack bus is given. Voltage for load bus 3 you have to assign as initial value of 1. From that calculation you can generate the voltage of bus 2 as well as bus 3. Okay. Is it clear?
Yes, sir.
Have you recalled the problem now? Okay. When you calculate that V2, V3, after several iteration, you will reach your desired destination. Actually 10 to the power -4 error limit will give you the result like this: V2 as 0.98 and V3 as 1. So this will be the result part for voltage, and then we can find the slack bus power, because slack bus, what information is given? Only voltage, right? Voltage magnitude and phase angle. So voltage magnitude is 1.05 V1, and V2 you have just now find, V3 as well as there. So from V2, V3 and V1 you can find the power, complex power for slack bus. Okay. So slack bus power you have determined. Then line loss for line loss calculation. complex power equation. We know the very basic complex power VI conjugate. Using that formula, we can generate what? We can generate the complex power. And to get that I want to, we know how to find that. V1 minus V2 multiplied by admittance Y12. Okay. So S12 is in your hand, S21. Those two are not same because multiplying factor of voltage. Okay. These are different. That's why your power is different. And that difference will give you the line loss. Here you can see positive sign. Here you can find negative. That means this is other direction. So when we complete the power flow diagram, this is the positive sign and this is the negative sign. That means the leaving current, leaving power is considered positive, entering power is considered negative. And by difference, we can generate the loss. This is the loss part, SL12, which can be found by difference from these two power. Okay, in terms of real power as well as reactive power. So real power, you have to mention in first bracket loss part, real and reactive power. Okay. So that was the before me problem. Now we will move to this problem, that the part where we want to discuss the start the discussion after mid. We have mentioned earlier. If we just think of this diagram, how many bars are there?
3 bus.
Right.
3 bus.
And which category was bus 1 is swing bus.
Slack bus.
Swing bus.
Slack bus.
Yes. Bus 2 is
Load bus.
load
Load
bus.
bus.
And bus 3.
Load bus.
Slack bus. Sir.
Bus 3 is actually
The generator bus.
generator or PV bus, right? Because power and voltage information is given. So for this problem, the bus 3 is the crucial. Okay, bus 3 you have to be careful because the voltage V3 is already, you have to maintain that voltage because it is the regulated bus. So after calculation, whatever you can get, you have to maintain that voltage to reach or to get the regulated or constant value by 1.04. So from the calculation, whatever you can get, say for example, calculation will give you 1.02. Okay. And in real part, but you have to maintain the your calculation to get that constant value.
Sir, what is the difference between bus 1 and bus 2? Sorry, bus 3.
Bus 3, okay. Bus 1 is the slack bus, it is the reference bus. Okay. Based on that reference bus, you can find the other bus like load bus or PV bus or generated bus, regulated bus. In bus 3, you can see the power information is given, right? But for slack bus, initially you don't have any information for power. That will be the major difference in terms of idea. And other part is for a system, you need to have some reference. Reference will be bus 1, but bus 3, this bus value of power or real reactive component can vary. Okay, well, slack bus power, you have the reference bus information on that value. That means you can simply compare the circuit by ground as swing or slack bus. Okay, in terms of that reference or ground or slack bus, you can consider the other bus information of voltage, right? V3 voltage, V2 voltage, based on that value reference, based on that reference. So this is the reference bus. Like nodal equation, when we have multiple bus, we need to assign one of them as reference bus, right? In that diagram also, bus 1 is considered as reference or slack bus. Based on that reference, we have we can say what is the value of other bus in terms of voltage. The difference here is power information for regulated bus will be given to you. Okay, but for slack bus it will not be given. You have to determine from the calculation. So now based on the earlier concept, what we can see, the power is there and the information is in impedance, so you can find the admittance by reversing or inversing. Then the real and reactive part is there. From that we can find the, as it is the load bus information, that's why it is negative. Okay, load bus will have negative sign, the scheduled power. In terms of complex power, and P3 is also here you can see what is the value of P. It is positive, right? If it is load bus, in that case it will be negative.
Negative.
Right. As it is the generator or regulated bus, it is positive. Otherwise, it should be negative. So using the earlier equation, which is the very general or basic equation, we can find the voltage for bus 1 as well as, sorry, bus 2 and bus. What are the unknown quantity? Here for bus 2 P, PQ are there, so you have to determine voltage, right?
Yes, sir.
Bus 3 PV is there, you have to determine Q. So Q you have to determine, as well as V3. What is the value of V3 from that? Q you can find, just what we have seen earlier, that it should be negative. Yeah, negative imaginary part Q. And if we just want to calculate or compute the voltage of bus 3, okay, value of Q3 is used to find the voltage for bus 3 VC3, which is calculated value of the voltage of bus 3. Okay, for the computation of voltage of bus. So this VC3 is the calculated voltage of bus 3. But earlier what we have been given, already bus 3 voltage is in your hand, right? Or the constant value is there. You have to keep the voltage in that value. So that for that what you have to do, you have to make the error calculation. Actually, to keep that value in 1.04, you have to take the imaginary part, and from there you can get some real part, and that real part is deviated from the calculated real part. So what you have to determine, V31 will not be the calculated values like this, but the adjusted error limit real component. Okay, this real component should be put there instead of calculated real part, and imaginary part will be same. You can see there, this calculated error part should be put there so that you can get the value of voltage 1.04, to keep that value of bus 3 voltage in that constant magnitude. Okay.
Yes, sir.
So
Sir, why imaginary part has no effect?
yes, real
Sir, why
part,
imaginary part?
actually if you use that value, that will not give you the response of that constant magnitude. That's why what you have to do, you have to do the reverse calculation to generate that real part, so that you can get the constant magnitude, because it is the regulated bus. Regulated bus should maintain that constant magnitude of voltage. Okay, when you get that calculation, that means when you make the what we can say, the real the complex part. If you just made the complex part r theta, or complex part in Cartesian, this is the Cartesian domain, polar domain, you will get 1.04, because you have to maintain that 1.04 all the time. Okay. For bus 3, that's why the circuit is known as regulated bus. Okay, not generator bus. It is the regulator bus. You have to regulate that voltage in that level. For that, what you have to do, you have to do the job accordingly to get that voltage. Okay. This is the crucial point for these types of problems, so that you can generate your voltage in that magnitude constantly. So for the second iteration, that is the response of first iteration, you can use that result for second iteration. And in second iteration, what we can get, V2 using that iterative procedure, after 7 iteration, we can reach the result.
Sir,
Yes.
the iteration part is very difficult for us.
Actually, for this type of problem, as I have already mentioned, when you have nonlinear equation, power equation is the nonlinear equation, right? So nonlinear equation requires the iterative solution. Okay, nonlinear equation, you cannot find the result by regular linear calculation.
Sir,
Yeah.
it is very time consuming.
Yes, it will be time consuming. That's sure. That's the correct response. But iterative solution is necessary for power flow equation. Okay, you cannot bypass that. You have
Sir, we have to show details every part.
Actually, you have to show first 2 iteration in details, then you can put the result. Okay, first 2 iteration you have to show detailed calculation. Then the remaining part, like this, 3, 4, 5, 6, 7, you can just give the calculation result. Okay, no need to show that. Yes, you have to write that 7 result. Actually, your result will be the ultimate V7, V27 or V37, like this, right? And this will be the accuracy response of, this is the limit, 5 into 10 to the power minus 5. Actually, what does it mean? It means on the 5th digit, you have the response of iterative response in what we have got, from the iterative response, we can find the deviation between 2 consecutive result, right? 10 to the power minus 5 means 1, 2, 3, 4, 5. 5th digit will have the deviated result. Real part is fixed already, but for imaginary part, you have to consider. Okay. Yes. Q3, this one. Yes, Q6, Q7, it's actually deviation from consecutive deviation. Okay. Actually, Q is not the major factor. V, value of voltage is major. Okay. V2 and V3, this you have to check whether your consecutive iteration, you can see V2 in 3rd digit you have only changed. Q is you can consider Q is the byproduct, or Q is the outcome due to that voltage. Okay. So voltage limit, you have to maintain that accuracy. Power, Q or P. P and Q is not the botheration point. Okay. Only the voltage issue, you have to consider that accuracy. If it is P, if it is Q, you don't need to bother about that. It is the actually outcome of the VN2 and V3. So the solution final result is there. Okay. Now here, the final response is already generated. Oh, load flow, when you have all the information, can you find the power between two bus, which is complex power S12? The result is already there. How can you find that? S12. How we can find S12? Any suggestion?
Sir, we know S1 and S2 individually, so we can subtract it from one another. Something like that.
Where you have got S2?
Sir, in the above iterations.
S1 is the complex power. S2 is not given, right? S3 is there. So S12 you have to find actually using VI conjugate, right? Using that VI conjugate. Okay. Voltage, you know, current between I12 you can find. How can you find current? You know voltage, you know, yes, impedance, or you can multiply that admittance. So you can find a current. And when you have current, you can use that complex conjugate and multiply the voltage to get complex power. Okay. So complex power S12 will not be same as S21. As why it is so, it is already mentioned, right?
Yes, so it's moving in the opposite direction.
Opposite direction, but in magnitude it is different. Why it is so? In magnitude it is different, right?
Yes, sir.
Why you have S12 different than S21? Okay, that should be same, right? Why it is different? Why S1 to S21? Like current, if we consider current case, I12 is same like I21, right? In negative polarity. But here
So
you
power
can
loss.
difference. Why?
So I think it is power loss.
Yes, power loss. Power loss will generate that deviation, and power loss. If we just consider that in terms of mathematics, how we can justify that S12 is not equals to S21? Why? In terms of mathematics, how we can justify that? That is due to the loss, but how we can justify in mathematics or derivation concept? Because S12 means what? Can you write the complete expression for S12? What will be the complete expression for S12 in terms of voltage and current? V1, I1, no. V1 into I12. Okay. When you write complex power, it will be, okay, let's go back to the earlier solution so that you can get the idea. This one. S12 will be V1 into I12 conjugate. Okay,
Yes.
that will be S12. And to get that I12, you have to use V1 minus V2 multiplied by admittance. Which deviation? No, not that reason. Actually, you can see the equation there. S12 is V1 into I12 conjugate, right? But what about S21? It is V2.
I2
We
only.
have difference, right? V1 and V2. This difference is responsible for S12 is not equals to S21. Though the current parts are same, voltage are different. Okay. So using that concept, can you find those power? You have S12, you have V1, I1, and you have Y. Let's go back to the our problem. What we have. Yeah. There it is. Now, can you find S12? The result is given. Can you justify that result? Right, I want to complement. Yes, you have to calculate that and H21 you can find. So when you can complete the calculation, you have to draw power flow diagram now. Okay. Up to now, you have the idea of impedance diagram, admittance diagram, reactance diagram. Now you have to draw power flow diagram. Okay. Can you complete the power flow diagram from this given information of complex power set? You have to use the arrow for real. Yes. Lower side. In imaginary real reactive part, you have to use arrow with a cross, right? Arrow with a bar sign. So try to draw that based on this given information. Complete the power flow diagram in your paper. Try to draw this complete power flow diagram for this given information. The result is already in your hand. Try to practice the power flow diagram in your paper so that you have got the idea clear. Yeah, you have done. What is the slack bus power? Have you got the information of slack bus real power? Slack bus real and reactive power. Have you determined that? You have to complete the total picture. Real reactive part is okay, but what about the other part? Like this is the real part. This is the one is from bus 1. This is attached to bus 1. This is attached to bus 2. So real part, reactive part, as well as line loss. Line loss should be mentioned in first bracket, right? In between in the line, first bracket, you have to line loss. So real part in the upper hand, reactive part in the lower hand. It is attached to first bus. Okay, let's see. This is the total picture of the power flow diagram. Okay, from the given information. So this is the real part upper hand, lower hand. This is for bus S1, 2, and this is S21. And what about the intermediate line loss, which is in first bracket, right?
Yes, sir.
So if this is the total picture of power flow, now can you find the real power and reactive power for the slack bus? Right, these two real components to get this total real power, right? For slack bus as well as reactive power. Here you can see this is the simple arrow is for real part. You have to mention also the arrow. Those arrow has the indication, or those arrow has the information. This arrow with a bar sign, it is the reactive part. All the lower part should have the arrow with one cut in between, right? So this is all about the power flow diagram. And what about bus 3? Bus 3, it is power, real power is there, right? What about reactive power? Reactive power, you have calculated Q. Q, it was what? Q7, right? Q37. Q37, it is 1.46, right? 1.46, it is in per unit. So you have to use multiplied factor to get the total power, which is 146, right? Q3 from the 7 iteration response. So this is the total power flow diagram from the iterative solution. Okay. Yes. Actually, the per unit calculation you have to back to real value by multiplying the per unit information of 100, right? 100 is the base value. Yes, base value will be there. Based on base value, you have to adjust the total or actual power. Okay. So up to now, what we have discussed, you know how to generate, if a circuit is given in terms of impedance information, you can find the equivalent admittance. Then you can draw the admittance diagram. From that admittance diagram, we can find the what? The admittance bus, Y bus, right? And from that Y bus inspection method, we can find Z bus. So Y bus, Z bus, the admittance diagram, impedance diagram. Now we have just now know how to generate power flow diagram. So this is the Z bus concept by inspection mechanism and power flow diagram from the observation. Beside that, we can find Z bus without having the idea of Y bus. Okay, by bus building algorithm known as bus building algorithm. Probably next week we will try to see that bus building algorithm, how we can apply to generate Z bus without having the information of Y bus. Okay, and after that we will try to cover the topics of fault analysis of balance type fault for the power system, which is three-phase fault, and it might be unbalanced types of fault, which is single line to ground, double line to ground, or line to line fault. Those will be unbalanced fault. So if you have any unbalanced fault in the system, first of all you have to generate the system equivalent of balanced type based on Fortescue theorem. Okay, so bus building algorithm to generate Z bus and Fortescue theorem to generate balanced circuit from the unbalanced network. We will try to cover upcoming class. Okay, and that will be the topics to cover this syllabus. So up to now, is there any question based on that power flow solution or anything else? In exam, you might have 4 bus maximum. In exam, you might have maximum 4 bus based on actually problem criteria. If you have to solve simple circuit, you might have multiple bus. If you have a power flow solution, you might have 3 to 4 bus maximum, not more than that. Okay, but if it is simple circuit, say for example, you have to generate Y bus, or you have to generate Z bus, or you have to generate the reactance diagram or impedance diagram, in that case you might have multiple bus. But for power flow problem, only maximum 4, not more than that in exam time. Okay. 3 in general, but maximum 4. So it is the Hadis-Adat chapter 6. Okay, Hadis-Adat chapter 6. So I think I have given the document to your CR. You have to check. This content is already delivered before mid. You might have this document with you. Okay, because some part is already discussed before mid. So you can consult with your CR also to get the content or material. So if you don't have any question, we may conclude today's session. Regarding mid, I think you have appeared, it was not so difficult, right? In mid exam, will it be difficult? Okay, actually from now on, as before mid, we have the foundation block. Okay, foundation block, how to generate or how to solve those issues. From now on, we will try to speed up our syllabus or speed up our journey, because we have already got the basic block in our hand, so we can utilize those basic block idea to solve the complex problem. From now on, the problem will be something complex than the earlier one. But if you are in regular class, in that case, it will not be so difficult. So thank you all for attending today's session. If you don't have any question, we can conclude today's session. From any question from anyone, try to practice this iterative solution problem. Okay. Otherwise, if you just observe or check, it will not give you the total idea. Okay. It will be time consuming, as well as you have to be very cautious or careful regarding the calculation. Otherwise, you may make mistake. So you have to practice. Otherwise, you may not get sufficient time in the exam if you just go through that. Try to practice those problems. Already it is solved, but try to solve by your hand. Okay. This problem, try to solve in your hand. What is the number of the problem? 6.8. Okay, example 6.8, as well as the earlier problem which is discussed before me, 6.7. 6.7 and 6.8 from Hadis-Adat book to get the clear idea regarding load flow solution. Okay. Okay. when you try to solve those problems, you might face the time management aspect. Okay, how to address those time management during the exam. Otherwise, in final exam, you may not get sufficient time due to less practice. So try to practice from now on so that you may not face any types of problem during that exam time in the final. Okay, that's my suggestion to you. Try to solve this 6.7 and 6.8 problem in your dormitory or home. Okay, thank you. Thank you all for attending to the session. If you don't have any question, I will conclude. Okay.
স্যার ফাইনালে কি মিডের স্যার
কোনটা? হ্যাঁ বলো। কি কে?
স্যার ফাইনালে কি মিডের স্যার মিড যুক্ত হবে?
Actually,
Mid
that
syllabus?
is what I can say, not the exact syllabus of mid, but the content will go. That means the impedance diagram idea, the reactance diagram idea, you have to utilize those basic block idea, right? Not exactly the mid syllabus, but it is the continuation of the course. So you might need to utilize those basic concepts for the after mid topics. I think
Sir,
I have cleared you, right?
স্যার সেটা ঠিক আছে স্যার, মানে আমি বলতেছি স্যার মানে স্যার মিডের টপিক কি স্যার ফাইনালেও থাকবে নাকি স্যার?
না, ওইভাবে থাকবে না, একেবারে ইয়ে থাকবে না, কিন্তু তোমার কন্টেন্টের যেগুলো ব্লক আছে এগুলো তো যাবেই, কন্টিনিউশন হবে। You will get the continuation of that topics, but not that syllabus. Okay, like reactance diagram. Actually, after mid topics, when you covered after mid, it will automatically require those basic block. Yeah, basic block will be required because you cannot move further for per unit diagram or per unit information. Not like exactly per unit diagram, it will be power flow diagram. In power flow, you have the per unit information. So not exactly the syllabus before mid, but you need to have the information from there. Like for this problem, the per unit normalization idea is utilized like that.
স্যার বেসিক্যালি আমাদের মানে এখানে যে কনসেপ্টগুলো লাগতেছে আগে থেকে সেইগুলোই লাগবে, বাকি মানে আর
কনসেপ্ট গুলো লাগবে, কিন্তু সিলেবাস রিপিট হবে না, ওইগুলো হয়তো থাকবে না, কিন্তু তোমার কনসেপ্ট গুলো কন্টিনিউ করবে। ঠিক আছে, ঠিক আছে, ওকে। এনি আদার কোশ্চেন? ওকে,
স্যার আই থিংক নো।
ওকে, থ্যাংক ইউ।